Now? Okay, so we're going to do 4.1. Some deja vu going on. So this section, this unit of notes, we're going to actually look at graphing quadratics. So in the last section, we were taking equations maybe like this, and we were presenting them to you like this. So we'd say solve, and we'd say 0 equals x squared. Okay? And what you were finding were the x-intercepts, because y equals 0. So we took our y value, we plugged in 0, and we're giving it to you like that. From now on, they'll be given to you like this. One of the steps you'll do is you'll be factoring to find the x-intercepts. Okay? So for this particular one, you guys told me that you square root both sides. So like this. And then you get plus or minus 0, which is really still just 0. So this represents the x-intercept. So if we were going to do a quick sketch of this one, which I hope we would probably end up doing on the next page anyways, but there's your x-intercept. And then for today, we're going to just look at table of values. So when y is 0, x is 0, if x was 1, and you're plugging it into y equal x squared, then y is 1, right? And then if x was 2, y would be 4, and if you plugged in x equal negative 1 and you squared it, you get positive 1, and if you plugged in negative 2, you get positive 4. So we can do a quick sketch of this thing. There it is. So we got the point 1, 1, and we got the point 2, 4, so we're up there. We got the point 1, 1, we got the point negative 2, negative 4, and it kind of curves off like this. So this is the graph of y equal x squared. Does it look fairly symmetrical? Yeah, it does. A couple of things to notice. Because of the nature of parabolas, usually if you reflect the point over the y-axis, you can find other points on the graph. So if I know the point 1, 1 is on the graph, then I know that if I just reflect it over, so make the x value negative, I'll have the same y value, right? Where did we see that in the table of values? Right here. Why did that happen? Where the point 1, 1 and the point negative 1, 1 is still on the graph. It's because of the squared, right? So if I plug in a negative, I still get the same y value. So the only thing that changes is the x value.
Good morning. Do you have Irina with you?
Yeah.
Could you have her come to the office for a moment, please?
Okay.
Thank you.
I guess rush back if I can. Okay. So we're just going to point out right now they're really symmetrical. Yeah, I think that's all I'm going to point out for now. Let's go to the next page. Okay. So basically, we'll do this on Desmos. We'll take a look at each one and then we can get a sketch. Or maybe I'll just do it. We already did the first one, right? Yeah. So if you want to if you feel like quickly resketching it, you can. I'll call off the points right now. So we got 0, 0, then we got 1, 1, and then we got 2, 4. Then we got the point negative 1, 1, and negative 2, 4. And there's y equal x squared. Right underneath it, let's do y equal negative x squared. Any predictions for what might happen here?
Still going to be positive.
Say again?
Bottom part?
Gonna be, what do you mean by opposite?
He just flips it.
Over which axis?
Y. Negative.
Yes. It's gonna flip it over the x-axis. So we can quickly make a table of values and see.
But doesn't the x squared need to be in brackets for it to be negative? Because it's like...
Yeah, so we're gonna square it and then we're gonna apply the negative order of operations, right? Do your powers first, then multiplication and division. Betcha. Yeah, so for y equals negative x squared, if you really quickly do a table of values here. So again, if you plug in x equals 0, you get y equals 0. So that's your x-intercept and your y-intercept in this case. And then if you plug in x equal 1, well, you go 1 squared and then you apply the negative, so you get negative 1. And if you plug in x equal 2, you get 2 squared, which is 4. Apply the negative, so you get that. So let's see. 1, 2, 3, 4. So negative 1 for x, or sorry, 1 for x, negative 1 for y, right there. 2 for x, negative 4 for y. So I can see that it seems to be opening down. If I plug in negative 1 for x, just really quickly, like you're going to go negative 1 squared and the negative on the outside. So what do you get? You still just get negative 1. Okay, so the y value stays the same, but the x value changed to negative 1, so there we are. And then if you plug in negative 2, you'll get negative 2 squared, which is 4. Apply the negative, you get negative 4. So something like that. So you learn a lot more about this in grade 12, but we have started covering it in grade 11 just to make it a bit easier when you get to grade 12. This is a transformation, okay? So if you compare it to the graph before, all that's happened is that the same shape and everything, it literally, all the points just flipped over the x-axis. So you take your y values and you just multiply them by -1 and you get the new graph. Okay, so if you want to draw an arrow here, and just write transformation. So flips graph over the x-axis, which means that you are just multiply y values on y equal x squared by -1. So this is how you describe it in English. It's flipping over the x-axis. This is what you do mathematically to obtain the graph. That becomes a big deal in grade 12. In grade 11 is kind of like, we're like, oh, look at this, isn't this nice? I'll talk more about it today. Hey, maybe the other graph, I'll just quickly pop up on Desmos and you guys can, I know, we'll do it. We'll do it. We'll do it the hard way with the table of values. How about that? All right. Ready to do this one? Let's do this one. All right. So, if you're using a table of values, you would just start picking some x values, popping them in, and hope that you get a graph. But we know enough that we can find the x-intercept, right? So how do we find the x-intercept? What's y equal to?
0.
0. So y equals 0. So this is popping back in the last unit where you say, well, 0 equals this stuff. And the direction would have been like, okay, solve this for x. Okay, so we can factor. Right, it's just one of those regular a equal 1 questions. Actually, it's a perfect square trinomial. What are my two numbers that multiply to 1 but add to 2?
1 and 1.
Mm-hmm. So x plus 1, x plus 1. What do I do now to solve for the x? That property.
It's 0 product property.
Yeah, 0 product property. Very good. I'd be so proud if you guys remember that in grade 12. 0 product property. So I take each binomial or term and set it equal to 0. Because I have the same one, I only need to do it once, right? No point solving the same equation twice. So you get x equal -1. So that's your x-intercept. Could we find the y-intercept? What's the x value for y-intercept? X equals 0. So that's easy, right? If you plug in x equals 0, well, that's gone. That's gone. So what's my y-intercept? 1. So once you do enough questions, you're going to start to realize the c term is always, when it's given in this format, is always the y-intercept. So I'll show the work just this one time. So there's my y-intercept. Okay, so we can start plotting that on the graph. Let's see why not. So x-intercept at -1. -1 and 0 for y. Maybe I'll use a different color. Hang on. Yeah, just give yourself a couple tick marks there, and there's the x-intercept. And then the y-intercept is at y equal 1. Okay. Now, because you kind of know the general shape of a parabola now, like you've seen them, they all sort of look like these U-shaped things. If you were going to fill in the rest of this with a table of values, so make your table of values here. Just pick a couple points. Okay, so I already got these two. Like, should I pick maybe one more over here? Like maybe like x equal 1, because that'd be easy to calculate? What do you guys think? Yeah? Like pick easy values. Like you're not going to be like x is 20, because then you got to plug it in here and you're going to get a big number. Okay, so if I plug in x equal 1, what do I get? 1 squared plus 2 times 1, so that's 2, 3, 4. I get 4?
Mm-hmm.
Yeah? I can write the work. Right? We just popped it into the equation. So you get 4. Okay, so when x is 1, over here, y is 4. 1, 2, 3, 4. Yeah, that's probably enough. So now I have enough to do this branch. And then I just need a couple points over here so I can see what happens. And then I'm going to show you something about the symmetry of these things. So should I maybe pick -2 over here for x, right? Just figure out what's happening just to the left of that. So -2. So I'm going to pop it in here. So let's see. I'm going to get 4. Subtract 4 plus 1. So overall, I get 1. So -2 and 1 for y. Let's make a prediction. So these things are really symmetrical. So if I know that I go over 1, up 1, check it out. If I go backwards, over 1, up 1, do you guys see how I did the same thing? Right? It wouldn't be symmetrical if I didn't do that. So if I go to the right one and up 1, if I reverse the direction on the horizontal and just go to the left one and up 1, I should have a point on the parabola. We've confirmed it's there. So how about this point? I go over 1, 2, and up how many? 4. So if I go over 1, 2, and up 4, my prediction is when I plug in x equal -3, I should get a y value of 4. Do you guys agree? Let's check with the table of values. If I plug in -3, so you're going to get -3 squared, which is 9. And then 2 times -3, so subtract 6 plus 1. What's that equal to? 9 minus 6 plus 1. 4. Beautiful. So our prediction seems to be valid. And there we go. So these things are symmetrical. So if you can find 1/2 of it, and then you use that symmetry rule where, notice how it changes every time though, right? Like the first time it's up 1, it's over 1, up 1. The next time it's over 2, up 4. So do these things have a constant slope like a line? No, remember lines, you have your slope and it's the same every time. So if you go between 2 consecutive points, your slope is the same every time. These things are curvy, so the slope is different at different points, okay? Just something to observe for now. Today's a day of lots of observations, okay? Because we're going to talk a lot about the properties of these graphs. So do you guys have any questions at this point? Like it sounds kind of scary, but technically, you can graph almost anything right now, right? Like you can find the x-intercept, you can find the y-intercept, you can grab a couple points on the table of values and get a graph. How many points do you think would be reasonable if you're graphing a parabola? Like for a line, you need 2 points, right? At least. For a parabola, what do you guys think?
4.
4?
So we change.
And maybe are there specific points we need? Like do we always need the x-intercept and the y-intercept? Yeah, so there's 2 points. And then we're going to talk about some terms here. The lowest point of the graph, you guys noticing there's always a lowest point? Or in this case, a highest point? Like this is as high as you ever get on the y values, and then you go back down. That's called the vertex. So that's another thing that everyone was like, okay, well we always want the vertex, we always want the intercepts, and then we want the general shape of the graph. So you're looking at about 3 or 4 points to graph a parabola. So basically what we're going to do in this unit is we're going to make sure that you can always find the vertex. And you can always find the x and y intercepts, which you already know how to do, so we don't need to do that. And then you can always find what I call smart points, like just an extra point or 2 that you need to get the shape. So that's half the unit. The other half of the unit is, hey, if I give you this, can you tell me what the equation is? And then we look at like 2 or 3 different ways to write the equation. That's the unit, okay? You guys kind of getting a sense of what we're doing for the unit?
That's the unit of now checkpoint, right?
I don't know what's going to land on the checkpoint. I haven't checked the calendar, but yeah. Yeah. Okay, we got one more. I don't want to spend a bunch of time on it, so I'm just going to go to Desmos and quickly sketch it. And you guys can write it in, and then we'll talk a bit more about properties. So -x squared plus 2x. Maybe a moment. Yeah. Okay, so write this in. I'll zoom in a bit. So the vertex is 1, 1.
They're still going back.
Yeah, I'm gonna highlight the 3 points that. Oh, I moved it. I'm highlighting the 3 points that you need to do your sketch. And then you got the general shape. So we could have done the whole same process. We could have found our X-intercepts, and we could have, the vertex is a little bit, no, we'll talk about how to find it. I don't know if we do that today or tomorrow, but yeah, but just get it in your notes.
Oh, that's fine. Can I get it in the room?
Okay, everybody have a chance to write it in? Okay. Excellent. So, what's next? Okay, now we're gonna go over a bunch of words and stuff. So, some of it we've already said, but this is just a quadratic function. So, what I would maybe add into that is a quadratic function. More than anything, so they give you a very specific example. I want you to write highest degree power is 2. Okay, when I'm talking about your degree, the highest degree refers to the biggest exponent. So the variable with the biggest exponent is maximum of 2. That gives you a quadratic function. Okay, it's also called a parabola. Here's the general shape, and we saw this graph. This is y equal x squared. All right. I want to point out that for a line, so here's the equation of a line. What's the highest power that you see? 1. So this is a line. And I'm just setting you up for grade 12 right here. Means that, well, you'll talk about this exact thing in grade 12, but in the context of power 3, power 4, power 5. Yeah. Okay? Now where'd I stick my pen? You can read that brown box. So the general form of a parabola or a quadratic looks familiar, doesn't it? Do you want to explain it to us back there, Tina? Oh, okay, good. What's this called? That from the last unit. Is this a trinomial, right? Is this a standard form of a trinomial? So that's the general form of a quadratic equation or a parabola. Okay? Questions? So if I ever say, hey, give me the equation in general form, you're going to give it to me like this. And we'll talk more about that, but for today, that's what we're going to talk about. Let's take a look at some more stuff. We already did this graph, right? So Can we skip this? And I already showed you with the table of values, so we'll just skip it. Let's just talk more definitions here so we can get this out of the way. We use a common language here. So again, every quadratic function is a curve. It's called a parabola. So here's some parabolas. The characteristics of a parabola are listed below. So we sort of chatted about this, but the vertex is the highest or lowest point. Okay, if you want to add only one. Like what I mean is it's either going to be the highest or lowest. You'll never have both. Okay? So if we take a quick peek over here, here's our vertex. And we call it a minimum point because it's the smallest y value. So when we're talking about minimum, maximum, we're referring to the y values, not the x values. Here's a vertex right here, and it's a maximum. So we say, hey, this parabola has a maximum. And the maximum is located at, and we would say the coordinates of the vertex. This one's opening down, this one's opening up. Okay. Down below, the axis of symmetry, it intersects the parabola at the vertex. Okay, and it's a vertical line. So for example, on this one, here's my axis of symmetry. So you would say x equals some number. Because it's going through the vertex, it's always the x value of the vertex. So if you want to write axis of symmetry and write x value of vertex, that would be something to stick into your brain tank later. Okay, here's the axis of symmetry on this one. It's also called the axis of symmetry because that's the line about which this thing is symmetrical, right? Like the right half, if you reflect it over, is the same as the left half. Do you guys see that?
So the vertex is always at the point of the axis.
The vertex is the highest or minimum point.
No, but
Yeah,
is
the axis of symmetry always goes through the vertex. Yes, excellent. Perfect. Kevin is synthesizing it for us. Yeah. People who generally, like culturally, like we find things that are symmetrical like attractive. So if you start looking at movie stars, I could grab a picture of Justin Bieber. Draw a line. Like if his head is tilted, to draw a line like this, the two halves of his face are like identical. Yeah. So the more symmetrical your face is, the more usually the higher you're rated on attractiveness. They do studies like this in university. Yeah, you can get computer programs to like figure out how symmetrical your face actually is. Yeah. Yeah. Anyway.
To break someone's up.
So like when I saw that, I was like, oh, like it's the axis of symmetry of the face. Do we have time? I would really. No, we shouldn't, because it's on YouTube.
I guess we can.
I'll show you after. I'll grab a picture of Justin Bieber or Brad Pitt. Brad Pitt's a really good one. He's super symmetrical, especially after all the plastic surgery. Anyway, yeah. What else? What else? What else? Oh, this is important. The gym people are shaking their.
What are they doing?
Yoga.
They're being a pain in the butt. That's what they're doing.
You should.
Okay, coefficient. If the coefficient of the x squared is positive, the parabola is going to open up and the vertex will be a minimum. So you're going to see this over and over again, but what it's saying is like, hey, if you have y equal x squared, what's the coefficient here? It's positive 1. Remember how this one opened up? Okay, so that's a really quick thing you can tell me about the parabola. When I give you an equation, if it's in general form, you can tell me right away if it opens up or down by just looking at the coefficient of the x squared variable. And you can say, hey, if it's opening up, it has a minimum. That vertex will be the lowest y value. If the coefficient's negative, well, remember when we graphed this one before, y equals negative x squared? It was opening down, right? It looked like this. It was that one. So if it's negative, it opens down, and the vertex will be the maximum, okay? So I really recommend that tonight you go through, you memorize all this stuff, so that we're using the same language, because I'm going to be using all these words. The domain. So remember, the domain is the possible x values that you can plug in. This is easy. For every quadratic function, it's always x element of the reals.
What?
Do you guys remember what that means from grade 10?
We never learned
You
it.
wrote it on the board and said you wanted to know this.
Yo, you do need to know it.
Yeah, we just said you didn't.
Yeah, grade 12, like every question's like, what's the domain? What's the range? Okay, well, all this is just a way of writing that x belongs to the real number system. That's just a fancy symbol. It's just an R. It's just got two little sticks and then like an R. What are real numbers again?
Every number.
It's like whole numbers.
Yeah, negatives, positive. What about fractions?
Those are in.
Yeah, like any number you can think of, any fraction, any decimal, those are all real numbers. What about square roots?
No, those.
Those are perfect.
Yeah, square roots are real numbers. Yeah.
Oh.
Yeah, so what this means is I can go to my equation. Let's say this is my equation. I can plug in any x value I want, and I can get a value for y. Does that make sense? So when you write x element of the reals, you're just telling whoever's reading it, any x value can go in here.
What's an imaginary number?
Imaginary numbers are just they're imaginary. It's a whole thing. I need an hour. Yeah. Yeah, but you might have noticed that our notes sometimes say there are no real roots. It means that in the real number system, there's no solution. In the imaginary number system, there is. Like you can have negative square roots, but I took a whole course on that, so I don't know how to explain it to you guys. It's not like a simple concept. Like some things are so complicated, it's like you need 20 hours before you can understand this one thing. So that's just not the point of this course. That's boring anyways. Yeah. Okay, so that's the domain. Domain is always, always, always x element of the real. I can give you any parabola, and without even looking at it, you can, in grade 11, you can tell me that's the domain, okay? Everyone's clear? So what's the domain of a parabola? X element of the reals, yeah.
Oh,
X
X
element of the
element.
reals. This is just the Greek symbol for the word element, by the way.
So what does element really mean? It's like it's in the.
Yeah, it means that X is part of the real numbers, yeah.
So what's an
Yeah.
X element?
Okay, the range is more complicated, but it's all the possible y values, and it's going to depend on where the vertex is, so that's a case by case. So when we figure out the range, we have to look at our graph or look at our equation, and I can't just say, here's the answer always, okay? But what I can tell you is it depends on the vertex. All right, what else? Right, parabola crosses the x-axis. There's either going to be 1 or 2 x-intercepts or no x-intercepts, okay? There will always be a y-intercept, but as far as x-intercept goes, there could be 1, 2, or none. Oh wait, they're called zeros. 1, 2, or none. Do I not have that? Right, it says if the parabola crosses the x-axis, there'll be 1 or 2, but also there can be none. We saw an example where there was, oh no we didn't, but here's a parabola. Can you guys imagine a parabola that doesn't have any x-intercepts? Like where would I draw it?
Just not.
Just don't, right, so like would this work?
Yeah.
Yeah, it's not cross, but does it cross the y-axis?
Yeah.
Can you ever imagine a parabola opening up or down that doesn't cross the x-axis? Or sorry, the y-axis?
Well, you can come up.
But that's different though.
Okay.
Yeah. Right, like no matter where, if I draw it over here, at some point it's going to cross. If I draw it down here, at some point it's going to cross. That's why we say there's always one y-intercept. Yeah.
How can there be one x-intercept but not two? Because if it's a parabola, it goes in like a.
What about this graph? When we drew it, did it not have one x-intercept? That was the very first one we drew.
You know, but like it's like a.
There's only one x-intercept.
No, but if it wait, hold up. So it crosses the x. But
Yeah,
it's kind of like.
it just touches it and off it goes. Yeah.
But how can it touch it? It has to.
Well,
Can't
it touches it at x equals 0, and then it goes,
Okay.
doesn't touch it again.
Okay.
Yeah.
You convinced me.
I convince you. Well, yeah, that's just telling you what happened. Okay, so guys, this page in your notes is super important because it's like basically most of the terminology that we're going to need to know for this unit. Okay? So are there any questions? It's just something you have to memorize, pretend it's biology class. You got questions?
If the range is still on y equals r,
Not necessarily.
because
No.
wouldn't you have to write y equals
Like
r?
here, let's go back and if you want to write, okay, let's do domain and range for this one. What's the domain?
XR.
Yeah, X element of the reals. The reason why is there's no restriction on what I can plug in here. Right? Like there's no division by 0, there's no square root. I can plug in any x value, I can generate an answer. The range, so look at, if you have the picture, doing domain and range is fairly easy. What is the lowest y value I have? 0. And can I equal 0 for y? Yeah, that's my x and my y-intercept, so I would write y greater than or equal to 0, comma, oh, is this what you meant?
Yeah, that's what I meant.
Yes. So this is saying y is an element of the reals as long as I'm greater than 0, I could have decimal numbers for y and stuff like that. Yeah, but the restriction is I have to be greater than or equal to 0. Yeah, so this is how we will write domain and range. Yeah. And we'll just do every question we do, one of the questions will always be what's the domain, what's the range. So every example we do, we'll be looking at it. Yeah. Eventually, like range is tricky. Eventually you might be able to sort of look at an equation and maybe imagine the graph. Like you need to know some stuff about the graph before you find the range. Yeah, there's no magic way to just look at it and be like, oh, this is the range. Like range is hard. Okay? So you either need to sketch the graph or you need to do a bunch of work to figure out what the range is. Domain is easy because you can look at the equation and in grade 11 it's always x element of the reals. Okay? Okay, you guys look so happy. The Asians are happy. They're like, I'm gonna get 100 in this unit. You can already tell. Yeah. All right. Okay, so I think we got some time. Yeah, we got lots of time. We're gonna do a couple more examples. But we're gonna do them this way. So I'm giving you a parabola. We're just gonna identify all the things we talked about. Okay? Can you just add little arrows on here? That's gonna bother me. That means it keeps going forever. Put a little dot here too for the lowest point, and if you want to put a dot there. Okay, see if you can remember. So which one of these points is the vertex?
It's the lowest point.
This one here. So vertex is -1, -5. And can we also write, is this a max or a minimum?
Minimum.
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 Yeah.
It's going
Minimum.
downhill.
So when it's opening up, the vertex is a minimum y because it's the lowest y value we'll ever get. What is the equation of the axis of symmetry? So that would be,
Straight line going
yes, the straight line that goes through the vertex. So what's the axis of symmetry? It's x equal,
Wait,
what did we say? The axis of symmetry intersects the parabola at the vertex. And over here I said it's the x value of the vertex, right? So what's the x value of the vertex? -1.
Negative.
So would we ever need to calculate the vertex or using the axis of symmetry?
So if I gave you one piece of information and I said, hey, the axis of symmetry is x equal -1,
Yeah.
now you know that the x value of the vertex is -1. Yeah. So that is useful, yeah, information. Okay, what are my x-intercepts?
2 and -4.
So -4 and 2. What's my y-intercept?
-4.
-4. I guess I should write y equal -4 and x equal. What's the domain without even thinking? Yeah, x element of the real. Now the range, if you have the picture, usually you can get the range. So we know it's a minimum. So it's going to be y greater than or equal to some number. And what's that number? The y value of the vertex.
-4. -5.
5. And then we go comma, y element of the reals, meaning that once you're greater than or equal to -5, we can have any number, any decimal number, whatever. Yeah. Yeah. Lost over. Are we feeling good about this? Yeah, you gotta go home and like memorize this stuff. Just pretend it's, I'm not like your biology teacher, I'm like, go home, memorize this entire chapter for tomorrow. I'm like, memorize 4 bullets. That's why I always liked math better.
Actually, it's go home and memorize half the textbook for tomorrow.
Yeah, so it almost boggles my mind when you guys complain about memorizing like 4 bullets. Anyways, let's do exactly the same thing for this. Alright? So, vertex.
3, 6.
3, 6. And is it a maximum or a minimum?
Maximum.
It's a max. And you want to write opens down. That's the reason why. So it's the highest y value you'll ever get. What else? The axis of symmetry.
This one is white.
So, what do you guys think? X equal 3. It's always the x value of the vertex. What else have we got? X-Intercepts. So let's see. We got -1 and 7. So x equal -1, x equals 7. And then we got our y-intercept. What's our y-intercept? 4. I don't know why I wrote intercepts plural. There we go. So y-intercept is y equal 4. Domain and range, I think are the last 2 things. So what's the domain without even thinking?
XDR.
Real power.
X element of the reals. Yeah.
Just calling it X.
Yeah, so it's weird. Like when you say it in English, you just say X element of the reals. When you write it, you go XER. Okay?
I will definitely forget.
You'll get it.
I'll forget what the words are for sure. I'll just remember the letters.
Math isn't really a language, but there's a lot of notation things about math. Now, the range. It's y less than or equal to 6. Very good. And then comma. Good. Have you guys started to notice something? When it's a maximum, the range is less than or equal to. When it's a minimum, the range is greater than or equal to. Does that make sense conceptually? If it's a minimum, it's always going to be bigger than some value. If it's a maximum, it's never going to be bigger than that value. All right. All right, I think if we have time, we do have time. Let's sketch a couple things. So it just says using a table of values. I will do a lesson later on, this is a transformation again, so if I cover up the +2, what's my base graph? Y equal x squared. Okay, and you're gonna notice, I'm gonna make a prediction. All that's gonna happen is my y values, I'm adding 2 to them. So if I took y equal x squared and added 2 to every y value, that's what this graph would be. So in grade 12, you do a lot of that. We do a little bit of that in grade 11. For now, we're just gonna use a table of values, okay? So we don't want to do too much today. So notice, this is basically every question you'll get. You need the vertex, you need the X and Y intercepts, axis of symmetry, domain, and range. Okay? So, do you have enough room here to do... Just gonna move this out of the way. Get out of here. That's fun. I like throwing stuff. My kid gets quite a lot of fun out of throwing things. Okay.
Oh, you see you throw him.
No, he likes throwing things. So, if you're finding your x-intercepts, I suggest you label your work like this: x-intercepts y equals 0. So it's easy for you to see, and it's easy for the guy who's marking it to see. So y is now 0. Now we're in the last unit. How do we do this?
You move the 2 over to...
Okay, move the 2 over here, so you get negative 2 equal x squared. Now what?
If you gotta square each side, but you can't square it.
Ah, so you square root both sides. But you can't. So can't have a negative root. Not the real number system. So what does that tell us about our x-intercepts?
It's in an imaginary number.
Yeah, it's extraneous roots. There are no x-intercepts. Be prepared for that to happen to you somewhat frequently. Okay? So you can't factor it, there's no x-intercepts. Okay, how about the y-intercept? What's x equal to?
0.
So again, I recommend that you always label it like this. So I'm going to go into my equation. You guys remember the shortcut? No work, what's the answer?
Just look at the 2.
Yeah, just look at the constant term y because that's 0, but if you're going to show your work, so 0 squared is 0, you get y equal to. I'm okay with you just jumping straight to the answer. Okay, for the rest of it, we're going to use a table of values. Alright, so I think we got some room over here. So we know that when x is 0, y is 2. So we're up here. Okay, now we're going to pick what I call the smart points. So for a parabola, you need some points to the right and some points to the left. So what would be an easy x value to choose?
Negative 1.
Negative 1, perfect. So you plug in negative 1, what do you get?
Negative 2.
Are you sure?
What are they? Oh,
Negative
wait,
1
never
squared
mind.
is 1 plus 2?
Oh, yeah. Never
Yeah. When I plug in positive 1,
3.
same thing. Let's start sketching. So when x is negative 1, y is 3. When x is positive 1, y is 3. Is that enough? By the way, is this opening up or down? Up. How do you know it opens up?
Because it's in the positive.
What is? Ah, that's what I'm looking for. Opens up because a is greater than 0, or in other words, positive, right? So I know it's opening up. So I know it's going to go like this. Do I have enough?
Yeah.
Yeah, you do. Would it be nice? We could do overkill and find another 2 points. So when you plug in 2, that would give you 4 plus 2, which is 6, and then you'll get 6 again here. So sure, we could do that. So negative 2 and 6, positive 2 and 6. There. So for a sketch, we're just doing a sketch. Now, I would lose marks for that because my vertex looks like it's off to the side and it should be there. I can't help it, this board, like where I draw isn't quite where it draws, so I'll do my best. But please don't do that on your paper. Make sure your vertex is here. Okay, what's the domain? Without thinking.
X, E, R.
X element of the reals. Double check, like, is there any X value that you wouldn't be allowed to plug in here? I can't think of anything, right? Like, there's no fractions, there's no square roots. I can plug in anything I like, I'll get a value for y. The range, so this is a minimum. So it's going to be y what? Greater than or less than? Greater than or equal to, what's the y value of the vertex? 2. Comma, y element of the reals. Cool. I mean, we could just shut this unit down right now. Like, you guys know everything you need to know. You can sketch a parabola. You're done.
That's it?
No.
Yeah. I don't know why we have like 6 lessons in this. No, but guys, technically, like, this is the unit. Like, you guys learned a way to graph a parabola. Find your x and y intercepts, use a table of values for the rest. Like worst case scenario in a test, there's no reason that I give you a question, and if I just say, hey, sketch this, there's no reason you should be able to sketch it, right? Like, can you always just do this? Yeah. We'll learn other ways that might be faster, maybe, but you can always do this, always. So you should never leave a question blank, right? Like you guys are capable of doing this. You've been doing that since like grade 10. You can make a table of values. You've been substituting values into equations since what? Grade 7? Something like that, grade 8? Doable? Okay, is there another one? Oh, it says do the same thing, but for x squared minus 1. By the way, was my prediction correct? I said if you took y equal x squared, which was this, and just added 2 to every value, you would get your new function. Let's see. Take your vertex, add 2, there we are. Take this point, add 2, there we are. Take this point. So what does this do? It adds 2 to the y values. So we say it shifts the graph up 2 units. So write that down. So, I don't know how to write this. X squared plus 2 shifts x squared up 2 units. There. I feel like maybe I should grab a question or two from the exercise. Can I borrow some of these exercise books? I think I left them in my room. Does anybody have an exercise book up here? Some hero with a cape? Who's going to be the hero that we need?
I could get it.
You're falling into the stereotypes that women can't be heroes? You didn't have your book?
Wait a minute.
You guys. I'm surprised Jasmine didn't have her book.
I do. It's at the bottom of all this.
Oh, so it's my fault. Oh, so it's a man's fault then, huh?
Yeah.
Oh, I see. You guys are funny. Okay, it's exercise 23. I don't see anything.
What if the equation's like y squared?
No, I don't see anything. My contact lens fell out. Let's get. I don't see anything like they give you a table of values and they say sketch it. It's pretty easy. When you get to question 5, you sketch a couple graphs, one of which we already did, but that's fine. So by the time you get to question 6, you've moved on to the review. How many people, like honestly, like you want to close your eyes for a second? I'm going to stop the recording.